All right, so now that you've learned how to solve systems of equations using graphing, substitution, and elimination, let's do a few application problems, some word problems. All right, so the best way I can suggest is to read the problem, highlight important information. I always cross out not important information because a lot of times, like all the words is kind of overwhelming. Then write out the system of equations. Choose which way you want to solve, whether it's graphing or substitution or elimination. Solve it and then check your work. All right, remember the steps for graphing, for substitution, and for elimination. I will say this. Graphing, it's best when it's in y equals mx plus b, when it's in slope-intercept form, when both of them are. Substitution is when x or y is by itself. And elimination is when they're in standard form. So like a number x plus or minus a number y equals a number x plus or minus a number y equals the number. All right, so each course at the Pease County Community College is worth either 3 credits or 4 credits. So let's just call the 3 credits. Oops, they're open. Let's call those the 3 credits is the x, 4 credits is the y. The members of the women's golf team are taking a total of 27 courses. So if you add them up, you get 27 courses. And they're each for a total of 89 credits. So you've got 3 credits and you've got 4 credits, and they're each worth, it's worth a total of 89 credits. All right, so this one is best solved either substitution, because you can get the x by itself or the y by itself, or you can do elimination. And we could like multiply the top maybe by like -3, or we could multiply the top by -4. I'm going to do, I don't know. What do you think we should do, guys? Let's see. Let's multiply the top by -3 and see what happens. All right, so what we get is -3x plus -3y equals, let's see, 27 times 3, -81. Then we get 3x plus 4, y equals 89. Right? So we have the same number, 3 and -3, but they're opposite signs. So when we add them, they go away. All right? And then -3 plus 4y is y. And -81 plus 89 is 8. So that means there are 8 courses of 4 credits. And then if we use this guy, and we plug in, remember 4 credits is y, so we're going to do x plus 8 equals 27, because that's the y value. Then we're going to subtract 8 on both sides, and I get 19. That means there are 19 courses of 3 credits. So those are my answers. 8 courses of 4 credits, 19 courses of 3 credits. Unless you specifically tell me, hey, this is the value of x, this is the value of y, it doesn't help for you to tell me x equals 19, y equals 8. You've got to like spell it out in words. All right, let's do this guy. Tickets at a local movie theater were sold at $5 for adults. All right, so A equals $5. Students is $3.50. If 230 tickets were sold, okay, so I want black. 230. Oh, 230 tickets were sold. This is an S. Any total of added student $880 were made. How many adult tickets were sold? All right, so before we did elimination, I'm going to do substitution this time, and I'm just going to solve for A. So that means it's 230 minus S. So if A is 230 minus S right here, I'm going to plug in 230 minus S. So I'm going to do 5 and see 230 minus S plus 350S equals 80. All right, then I need to distribute 5 times 230. 5 times 230. 1150 minus 5S plus 350S equals 880. All right, I'm putting up here. We're going to combine like terms. So I get 1150, negative 5S plus 350. So negative 5 plus 3.5 is negative 1.5S equals 880. And then that 880 is a regular number, so I need to move the other regular number, the other constant. So that cancels. So I get negative 1.5S equals 880. That, hang on, you can't even know what I wrote right there. All right, negative 1.5S equals negative 270. All right, and that 1.5 is being multiplied. So I'm going to divide by negative 1.5. And those negatives are going to cancel. So I get a positive 180. So that means that 180 student tickets. So if there were 180 student tickets, then A plus S was 230 and S is 180. Then I need to subtract 180. So I get A equals 230 minus 180. So I get 50. So there were 50 adult tickets. And that's our answer right here. Because that's what they asked, just how many adult tickets. All right. Do one more. The cost for admission to the art show is twice as much for adults as it is for children. For children, let's do a C instead of the S. All right, the total price of admission to the art show for 3 adults and 12 children, so 3 adults and 12 children is $90. Find the price of the admission to the art show for a child. All right, so I just took the words that they said and put them like in an algebra thing. 2 times some amount as an adult. That amount is the price of the child. Then they have 3 adults and 12 children is $90. Now I need to solve and find each one. But I can't have different letters in the equation. I have to have the same letter. So where the A is, I'm going to put 2x. Where the C is, I'm going to put x. And figure out the price of the child. That's what that stands for, the price of the child. So I get 6x plus 12x equals 90. All right, well, 6x plus 12x is 18x. And when I divide 90 divided by 90 divided by 18, I'm sorry, I get 5. So that means a child, $5 per child. And I'm just going to solve for the other thing just in case, okay? So if a child is $5, then 2x is an adult. That means that 2 times 5 is the adult. So it's $10 for the adult. All right? Fabulous. And if we wanted to check it, we could, right? So let me show you how to check it. So $5 here, $10 here. So if we did 3 times 10 is 30 plus, so $30 plus 12 times 5, 12 times 5, oops, 12 times 5, that's 60. So 30 plus 60 is 90, so it works. So price of the child, so $5 is your answer. All right, so those are the only kind of application problems. This one right here is as hard as it's going to get for the application problems. With that twice as much, and then the math side of it where you've got, you know, funny numbers is kind of tricky. But you can solve them elimination or substitution. Good luck on your homework.